Alright, welcome back everybody. In this video we're going to look at the form infinity minus infinity and how we handle using L'Hopital's rule then. The whole game plan being that we're going to manipulate this expression algebraically to turn it into something of either the form 0 over 0 or infinity over infinity. And if you think about what's happening here, if I try to evaluate this, I've got 1 over the sign as x approaches 0. And the sign of x approaches 0 as that happens. So we've got 1 over something approaching 0. So that approaches infinity. Same for 1 over x. And so we have the form infinity minus infinity. And so we want to manipulate this algebraically and turn it into a fraction so that it's either 0 over 0 or infinity over infinity. In order to do that here, it's relatively simple. All I'm going to do is find a common denominator. And the common denominator is going to be x sine of x. And when I do that, the new numerator becomes, let's see, I multiply the first fraction by x over x. I multiply the second fraction by sine of x over sine of x. And so there's my new numerator. And if you think about what's going on here algebraically, you've got 0 minus 0 over 0 times 0. As x approaches 0. And so we've got something of the form 0 over 0. And so it'll be appropriate for us to apply L'Hopital's rule here. So we'll take the limit as x goes to 0, and now I take the derivative of the numerator, which is going to be 1 minus the cosine of x, and the derivative of the denominator, which is going to be sine of x plus x cosine of x. And then I see what happens. And as x approaches 0, the numerator becomes 1 minus 1. The denominator becomes 0 plus 0 times 1. And we still have the indeterminate form 0 over 0. So I'm going to apply L'Hopital's rule again. We've got the limit as x goes to 0 of the derivative of the numerator is just going to be sine of x. And the denominator is going to be cosine of x plus 1 times cosine of x plus x times the derivative of cosine, which is negative sine. And so this simplifies to limit as x goes to 0 of sine of x over 2 cosine of x minus x sine of x. And if I evaluate this as x goes to 0, I've got 0 over 2 minus 0, and so 0 over 2, and so this limit ends up being 0. Alright, let's go on to example 6. Taking the limit as x approaches 1 from the right of this quantity, and this is again the form infinity minus infinity, because the natural log of x approaches 0 as x approaches 1 from the right. And so that's going to be 1 over something approaching 0, which gives us infinity. And again, we've got something of the form 1 over x approaching 1 over 0. So again, the second fraction approaches infinity as well. So we're going to go ahead and find a common denominator. We've got the limit as x approaches 1 from the right of, and now my common denominator is just going to be the product of those two denominators. And now if I look at what's going on here, I end up with 0 over 0 again. And so I'll apply L'Hopital's rule and take the derivative of both the numerator and the denominator. The derivative of the numerator is going to be 1 minus 1 over x. The derivative of the denominator is going to be, let's see, natural log times the derivative of x minus 1, which is 1, plus quantity x minus 1 times the derivative of natural log, which is 1 over x. And if I try to evaluate this, let's see, I get 1 minus 1 over 0 plus 0 times 1. So we've got 0 over 0 again. And boy howdy. Now I could opt to simplify this a little bit before I go applying L'Hopital's rule again. It may be advisable for us. I'm just going to multiply everything in numerator and denominator by x to get rid of those fractions. And that turns this into this as our limit. Again, still 0 over 0 because all I did was make a reasonable algebraic manipulation. And now I'm going to apply L'Hopital's rule again. And so this turns into the limit as x approaches 1 from the right of, and the derivative of the numerator is 1. The derivative of the denominator is x times the derivative of natural log, plus natural log times the derivative of x, and the derivative of x minus 1 is just going to be 1. And so if I take this limit as x approaches 1 from the right, I've got 1 over 1 times 1 plus 0 plus 1, and that's going to be 1/2. And that is our limit here in example 6. Alright, so we saw in this video how to handle indeterminate forms of form infinity minus infinity. Some algebraic manipulation to turn it into either 0 over 0 or infinity over infinity, and then just go ahead and apply L'Hopital's rule. Alright, that's it for today. See you guys next time. Have a great rest of your day.